All right, let's do Chapter 10 example problem for correlation and regression. I took this one from the book. In a survey of statistics students at Hope College, two of the questions asked were the current GPA, grade point average, and how many classes they failed to attend in the past 3 weeks at the college. The data can be found here. Let's explore whether or not there's evidence of a strong association between these two variables. Okay, so how many classes they missed, that's a quantitative variable. Their GPA, that's a quantitative variable. So we've got two quantitative variables. It's a perfect setup for making a scatter plot and doing a linear regression. So they want to know what the null and alternative hypotheses are, do a simulation and find the p-value, summarize the conclusion, and then talk about cause and effect. Okay, so let's jump to the applet and see what the data looks like. So we need the correlation regression applet here, and then we clear this out and paste in the data for missing class and GPA, which is here below, and then we click use data, and there we see the scatter plot. And just looking at the scatter plot, I would say there's a lot of dots here, maybe some negative association, but I mean not super strong. But if I had to say, I would maybe say there's a slight negative association. We'll find out if we show the regression line. Oh, okay, yep, there it is. Okay, so it's a little bit stronger than I thought. There must be a lot of dots here and then kind of following down here. And the equation is the predicted GPA is 3.59 plus a negative 0.1496 times the number of classes missed. So that's the regression line based on our sample data. Now the question actually asked us to do a simulation and determine whether this slope here is significant or not. So let's set up the null and alternative hypothesis. So the null hypothesis would be that there's no linear association between GPA and the number of classes missed in the previous 3 weeks. The alternative is that there is one. We can think of that in terms of the slope. So the true slope is 0 or it is not 0. So the true slope between of the regression line between number of classes missed and GPA is 0 or it is not 0. And I guess the p-value is going to be 0. We'll see that in a minute. So let's try that. We'll go over to shuffle. So if we shuffle once, we want to select slope here. Okay, so it selected slope for us. If we shuffle once, what we're doing is we're randomizing all of these GPAs based on the number of classes that they missed. That gives us a new scatter plot. This time it looks like this. And we still have a negative association here, slightly negative. And so we plot that slope on the plot right there. Then we shuffle them again. Oh, this time it was positive. We shuffle them a whole bunch of times. Each time we randomize the y values for the given x number of classes missed. And when we do that, we get our null distribution. If we do it 100 times, it looks like this. If we do it 1,000 times, it looks like this. So that's a nice bell curve shape, which is typical to what we'd expect. And then we can see whether our regression line here is typical for what we would see if there really were no association or if it was something out of the range. And I would say this is atypical. The regression line slope that we observed is negative 0.1496. So if we go to negative 0.1496, count up how many times that happened. It never happened. So we never observed a slope anything close to this when we assumed that there was no association by randomly shuffling the y values. And therefore, we're fairly confident that what we observed is actually significant. Okay, so the p-value is 0 right there. And we could have done that as a theory-based test as well if we wanted to. by just clicking the, let's see, regression table right here. Sorry. If we click this, it gives us the slope that we observed, and it gives us the p-value. So this would be doing a theoretically based p-value, similar to how our null distribution is a bell curve. It sort of just assumes that and then does the computation for us and gives us a p-value of 0 and a t statistic. So this is how we know it's quite extreme. It's more than 5 standard deviations of the null distribution away, what we observed here. Okay, so let's go back to our thing. So the p-value is 0, and the question they wanted us to answer was then to summarize a conclusion. So if the p-value is 0, then what do we conclude? So we conclude there's very strong evidence of a negative linear association between the number of classes missed in the previous 3 weeks and the GPA, at least for students in statistics classes from Hope College. I believe that was the population. Survey of statistics students at Hope College. So you can talk about generalization. While the sample was based on stat students at Hope College, so that would probably be the population to generalize to. Maybe you could generalize it to all students at Hope College if statistics students are a wide enough range of Hope College students in general. And then I wrote out a sentence about the 95% confidence interval. So let's see, how do you get the confidence interval? Well, once you do the regression table, you can just click this button and it makes it for you. This is a theoretical based confidence interval. And so before we do this, we should probably at least check that, that our validity conditions are met. We've got a good size sample, 95. We've got points above the line, points below the line. There's spread here, there's some spread here. It doesn't look like the spread is changing all that much as we move along. So I think the validity conditions are met, and so we feel good about our confidence interval here being theory-based, and that's what the numbers are. So we observed a slope of negative 0.1496, but of course that's just our statistic. We are trying to make a conclusion about beta, the true slope, for all students in the population, not just the ones in our sample. And so what we would say is we're 95% confident that the true slope of the linear regression in the population of Hope College statistics students, or maybe even Hope College students, between the number of classes missed in the previous 3 weeks and GPA is between negative 0.2042 and negative 0.0949, which means that for each additional class missed, we predict the GPA to decrease by somewhere between 0.0949 and 0.2042 points. And again, notice this is the predicted GPA, right? This is not saying anything about what really happens. We're saying, what does our model predict? Because if you look at what really happens, well, here's several students who all missed 4 days, and they all have very different GPAs. So the model predicts a general negative trend that the more classes missed leads to, lower GPAs. But this is sort of on average in the model. I mean, this student has a very high GPA, even though he missed 5 classes in the last 3 weeks. So it is not about each individual person. It's sort of, what do you generally see in the data? And the other thing, which the question I believe says, is would you make a cause and effect conclusion about this? Well, I would say no, you should not conclude cause and effect, because this was an observational study. We should be cautious to conclude that the number of missing classes is causing the decrease in GPA. In one sense, your GPA is based on courses that already happened, not even the current course. But it's far more likely that there's some other factor that's causing both. That something that causes students to miss class also causes them to have slightly lower GPAs as, compared to the number of classes or something. Not the other way around. And so in this case, you just want to be careful about that. It doesn't mean that there's no connection. It just means that we're not establishing a cause and effect. And just if we go back to the applets, we talked about the confidence intervals, talked about the coefficient, the p-value, the t-statistic, seeing the null distribution. So again, this is various slopes. Another thing is we could have done the same thing for correlation. If we get the correlation, that's negative 0.49. So that's a moderate negative correlation. The r-squared value is 0.24. So this is saying that something around 24% of the variation in GPA is explained by the number of classes missed. Now, just because it's explained by doesn't mean it's caused by, but there's a lot of variation in GPA for all these students all miss 0 days and have a lot of variation in GPA. But if you look at the total variation that we see here in the data, about 24% of it is explained by the linear relationship based on the number of classes they missed. And that's kind of helpful to know. How predictive is this? And you can think about, warning signs. Well, if a student misses several classes, is that something that maybe you want to act on? So there's things about the way you can use statistics to actually make decisions in the real world, which is good. All right, well that concludes that problem. I think it's a nice one. It's in the book, and there's other ones to practice in the book as well.